So today we're going to talk about two of your favorite things, related rates and analyzing graphs. So here we have this graph of a function. It's a piecewise function, as you can see, with a line here, a different line segment, parabola, another line segment, and another. So when we're talking about related rates, we're really talking about what happens to one variable as another variable is changing at a given rate. So, for example, if we were to talk about the rate of change of y as x changes. So, looking at it graphically, let's say x is moving along here, and x is changing at a constant rate. The question is, how is y changing at the same time at different places? So, for example, what is when x is -7 and x is changing at a rate of dx dt equal to 3, what is dy dt? Right at that point, -7, when x is changed, when dx dt is 3, what is dy dt? Well, we should be able to see the slope of this line, and we recognize that the slope of this line, from this point to here, it's a slope of 2. So as x changes by 3, y is changing by 6. So the related rate when dx dt is 3 and x is -7, dy dt is 6. As we come along our curve anywhere along this line, but we'll talk about at -4, here we see a slope of 1/3. So if dx dt is 3, changing at a constant rate, then dy dt is only 1. So x is changing at the same rate, but y is changing slower. As we come along here, of course, we've got a curve. We'll come back to that. In this chunk, if dx dt is 3, what is dy dt? If you look up here, you can see that from 2 to 4, this function is -3x. So if dx dt is 3, what is dy dt? In the time it takes x to go 3, y changes by 9. So dy dt is -9. And over here, very simple. What is dy dt? If dx dt is 3, what is dy dt? Well, of course, it's 0. So that's really the idea of what we're doing with related rates. And obviously, this is a simple one. We'll look at a more complicated one in a little bit. But what about on this curve? If dx dt is 3 and x is 0, what is dy dt? How fast is y changing at the point 0? Obviously, we can't look at the whole curve and figure out a slope, so we've got to find the slope at a given point. That's easy. That's the derivative. And right here, it's obvious that we have a horizontal tangent, so the derivative is 0. And so when dx dt is 3 and x is 0, dy dt is also 0. As we move along, since this is the x squared curve, if we were to look at, say, -1, the derivative, this is actually x squared over 2, so the derivative is x. So if x is changing by 3, so is y, because y is changing by -3, because the derivative is -x. As I said, we'll talk more later. We'll actually play with a function that's not this piecewise and see how do we find these related rates with a more complicated function. But that's just a very brief overview of what we're doing with related rates. X is changing at a constant rate. How is y changing? If x is changing negative, then we just use negative in our formula. So here, x is changing by -3. Well, the slope is 1/3, so y is changing by -1. Here, if x is changing by -2, y is changing by +6, because the slope is -3. There you go.